This
Sorry.
conference will now be recorded.
So yesterday we did reference lines, reference band, reference distribution, and we are supposed to discuss bullet chart, right? So we'll do a recap on that concept and do bullet chart. I'll get connected to Sample Superstore first. So we did this example where we looked at the sales for different categories, further broken down at subcategory level. Now, what is a reference line? Reference line is simply a line that would act as a point of reference, right? So where do we put a reference line? Reference line can be put only with respect to the continuous axis, numerical axis. When you right click on that axis, there is an option to add a reference line, which you will find on the menu. When you select it, you will get the window which will help you to add a reference line or a band or a distribution or put quantiles and all that there for box plot kind of a thing. So reference line is a line that acts as a point of reference. Simple. You can have the line either as a table scoped line, which will pass or work on the entire data in the chart, and then it'll put a line there. So this is the average of all the values that are there on the graph. Or you can have a pane scoped line which acts at pane level, or you can have a cell scoped line. Okay, now when we have a cell scoped line, what is happening? It is a cell scoped line, which means it is working on the value, individual value. And when you take the average of a single number, what will happen? We will get the number itself. That's why you see the line is basically at the tip of the bar. Whether you say average or minimum or maximum or median or sum or total, it really does not matter in this case, right? Because it is a single value. It doesn't matter how you are aggregating it, you will get the value itself. That is why it doesn't matter what you do if it is per cell. However, this is very significant, very significant if you are going to put the reference line with respect to any other measure. Okay, if your reference line is going to indicate some other measure, then it becomes very significant. That is the concept we will use to transform the chart into a bullet chart. But before we get there, let us go back. So you can see I have a pane scoped reference line that is going through the minimum, means minimum per pane. Here furnishings, here fasteners, and under technology side, you can see the minimum is from copiers. So that is a reference line. Next thing we get to choose is, after choosing the aggregation, next thing we get to choose is how do you want to label the line. You can either choose not to label the line, or you can choose to label it with the value that it is representing. You can choose to label it with the computation based on which the line came up there, or you can choose to label it with your own in your own way by choosing to customize the label, right? So you, like, say for example, computation followed by an equal to sign and then the value itself. Why is it not accepting the value? Okay, this is the tooltip where I'm modifying. So I'll change this at label level, computation equal to, and I'll make it the value itself. All right. So now what happens? The tooltip also I have updated to show computation followed by value. Label also is computation followed by value. So that is what it is. Next, we discussed about how do we put a reference band. Same method, again you right click on the axis and you choose to add a reference line. When you get the window that will help you add the reference line, choose band. Then you choose what should be the scope of the band. Band is something that will stretch from a certain minimum value to a certain maximum value depending on what you give here. So you can have the band between two fixed constant points also, but here we will make it go from average to maximum. Okay, so reference band going from the average to the maximum. So that is how we put a reference band. Finally, reference distribution, we will talk about it in a moment. Okay, so we know about reference line, we know about reference band. We know reference distribution is something where we can put it based on percentage, we can put it based on percentile, based on standard deviation, or box plot kind of quantiles kind of a thing we can put. But what are those? We shall discuss when we do box plot, quantiles and all. But for now, let us go ahead and look at bullet chart. Bullet chart or bullet graph, anything you can call it. Please get connected to coffee chain data source for this example. Get connected to coffee chain data source. I'm getting connected to the Excel version of coffee chain that I have. So I don't have to perform any joins here. Directly Excel coffee chain, and I will go and try to create a bullet chart. All of you please get connected to it. I'll give you a moment. All right, now here let us say my requirement is this. I would like to compare the profits of different products. Now coffee chain is a business where different types of coffee and tea related products are being sold, and they have made some profit. Every product has made some profit here. Okay, now every product is also given a target. Okay, quickly get connected.
Is it okay if I connect to MS Access? Excel I'm not able to find.
Yeah, that is also fine. MS Access
Okay.
is also fine. But if you're connecting to MS Access, just get connected to all the three tables.
Sure.
Fact, then join with location and product. Data set is coffee chain. Funny. Coffee chain. Either Excel or Access, anything that you have. Funny, it should be there in your dataset folder which you download from AI Sprite. Otherwise, you can also download it from the drive link that I shared. Yeah, anything is fine. So I was thinking all of you will have coffee chain because you have done data blending using coffee chain. We have learnt about custom SQL queries using coffee chain, right? Yeah, even then you should have practiced data blending with it, right? You should have practiced custom SQL query with the Access version of coffee chain. All right, no problem. Get connected to it if you're not having downloaded, and we'll proceed. So every product that is being sold by the coffee chain business, there is some profit associated with it. Okay, but for every product, the business has also given them a goal or a target that the product is supposed to meet or achieve. That target or goal is present in the field named as budget profit. Budget profit, in some versions of coffee chain, it is called as target profit. Both of them are the same. Now, I want to show the target, which is the budget profit, as a reference line over here. I would like to show the target as a reference line. Then how to do? When I right click on the axis and choose to add a reference line, and if I go here, it is going to put the reference line. I can have a cell scope line, but it is going to put the line based on the profit value itself. We don't want a reference line based on the profit. We want the reference line to represent the target profit or the budget profit, right? Our reference line is supposed to indicate the budget profit. Now, how do we make it indicate budget profit? So here, not possible. I will turn off the mark labels. What I will have to do is I have to make budget profit information available to the graph. Okay, so we created this chart and now we are trying to make budget profit information available to the chart. How do you make it available to the chart without visually impacting the chart? Measure. We can take it to the detail shelf. So when I bring it on detail, what happens? It is a part of my graph now. It is available to my graph now. It's just that visually it did not get represented. All right. So now how do we put it? Right click on the axis and choose to add reference line. When you add reference line, what is it? The reference line is supposed to represent what information? The target given for each product, the target profit that each product is expected to achieve. Correct? So what should be the scope of the line? For every product, I have to show its target and indicate whether or not it has met the target. So what should be the scope of the reference line here? Should we go with a table scope line, pane scope line, or cell scope line? All of you will agree that we have to go with a cell scope line, right? Cell scope line. So we will go with a cell scope line. And what is the value based on which we want to? What is the value based on which we want to put our reference line? The value based on which we want the line to come up is budget profit. The value based on which the reference line is to come up there is budget profit. So you have to choose budget profit as the value. Now, will it matter what aggregation we use? Agreed, no? It will not matter what aggregation you use, right? Why will it not matter? Because the budget profit for every product is one constant value. Whether you take the average of that number, of that goal, of that constant value, or you take minimum of it or maximum of it or median of it, it does not matter. For a cell scoped reference line, the aggregation does not matter. Somehow Tableau people have not updated the interface in such a way that when we say cell scoped, they should actually remove this aggregation. It doesn't work that way. So what we will do is we have to choose some aggregation. You can choose anything of your choice. It doesn't matter. You will get the value itself. Are you all with me on this? Any confusion here? Why I'm telling it will not matter what aggregation we use here? Okay. So here it's like this. Now every product has been given a target profit, which is budget profit. Okay, so we want a reference line indicating this number or that value there on the graph. For Amaretto, the budget profit or the target is 7,020, which is what should come up in the reference line. So when you have a single number that you have to show in the form of a reference line, 7,020, will it make any difference whether I tell Tableau to show the minimum of 7,020 or maximum of 7,020 or average of 7,020 or median of 7,020 or anything? Will it matter how I aggregate it? I know I have to show 7,020, but Tableau expects me to put an aggregation. Right. Okay, I got your confusion. It is sum of budget profit that we are looking at. It is already aggregated at product level, right? It is the summation of budget profit. The reference line is already based on summation of budget profit. You don't have to further aggregate it. Correct, Mayur? We are already putting a reference line based on summation of budget profit, which we need not further aggregate. In the previous case, it is not like that. Though we are looking at sum of sales, we are aggregating it because from four different sum of sales values, we are picking up the minimum of that. We are taking the average of these four sum of sales values. We are checking what is the maximum of these four sum of sales values. So their aggregation matters when you're going at pane level or when you're going at chart level, that is table level, aggregation matters. Okay, you're taking the minimum of the sum of sales value. Each bar is representing sum of sales. Here, it does not matter. Sales code. Okay, everybody okay with this, right? Very important concept. Okay, let me edit that reference line. So it really does not matter in this case when I'm going per cell, how I aggregate it. But I will not confuse the person who is reading the chart. They may not know all these concepts of aggregation, etc. So what we will do is when we are labeling it, let us not label it. Or if you label it, don't label it with the computation, label it with the value. Let us not confuse the end users by putting aggregation in the label. Don't put aggregation even on the tooltip. Customize the tooltip also. Tell them that this is the value. That's all, enough. Okay. So handle the label, handle the tooltip in such a way that think from an end user's perspective, who will not understand all these aggregation, etc. They just need to see the number. We'll show them the number itself. If you want, you can change the color of the line. You can make it look dark and you can make it thick. Okay. So that is my budget profit. Okay. Please, all of you put this reference line on the graph. Okay, I hope all of you are able to do this. I hope you all have the reference line indicating the budget profit. Make sure you have handled the label and the tooltip. It should be informative, okay, not confusing. Now, so when you look at this graph and when you try to read the graph, what do you understand from it? So if I ask you, the first product, Amaretto, did it reach the target or not? Did it reach the target? Okay, I hope all of you are following. It did not reach because the target is here and the bar stopped here. It made a profit of only 4,890 when in reality it was expected to make a profit of 7,020. All right, so it did not reach the target. Now you can change the fit of this chart to entire view. When you change it to entire view, it will expand and occupy the whole space on the canvas. So you can change the fit. And if you want, you can reduce the size of the bars slightly. How do we reduce the size? You click on the size shelf and pull the slider down. So the second product, it definitely went beyond the target given to it. Third product missed the target. Fourth product went above the target that was given to it. So we understand wherever the bar has gone beyond the reference line, it has met the target. Wherever the bar could not reach the reference line, it missed the target. Right? Clear, no? This is clear. A cell scoped reference line, how it helps us, what is its purpose, should be clear with this example. Any questions here? Now, to convert this into a proper bullet chart is nothing but a graph which compares two measures against each other. It compares two measures against each other, bullet chart. So I know what is the target, I know what is the actual value, I know whether a product has reached the goal or whether it has missed the goal. However, in a proper bullet chart, it's not just the target that is given as a reference. We also must represent 60% of that value and 80% of that value. Means what? I should tell Tableau to compute 60% of this number and what is 80% of this number, and that should come up as a reference band. Means distribution, reference distribution. I need to put reference distribution here. How do we put a reference distribution? Same procedure. Right click on the axis and choose to add a reference line again. This time what we are trying to add is a reference distribution. Okay, select distribution. And what is it that we want to add? A cell scoped reference distribution. Cell scoped reference distribution, indicating what? That is important. Indicating what information? That is important. Indicating 60 and 80%, 60 and 80% of budget profit. 60 and 80% of budget profit. Again, that is going to be a constant value. It does not matter what aggregation you use here. Don't label it. Don't label it. Make it none. And tooltip also, let us just customize and show the value only. Or computation equal to and value. Okay. So please put a reference distribution indicating 60 to 80% of budget profit. Does not matter what aggregation you use again. And don't label it. Label might confuse the end user. Okay. Now, so 7,020, 80% of 7,020, 80% of this value is 5,616. 60% of this value is 4,212. 4,212. 80% and 60% of 7,000. So that is what is this indicating. 60% of 10,100 is 6,060. 80% of it is 8,080. And you can see the reference distribution going from 60 to 80%. All right. Now you can further improve the look of this reference line. Let us edit it and choose the distribution to edit. I want to edit the reference distribution, which is going from 60 to 80% of average budget profit. When it comes to the fill, you can fill above. The whole space here will be filled. You can fill below the band. So this is the reference distribution. Above the reference distribution, we filled everything. Below the reference distribution, we have filled everything. When you are using this, you can also use a different shade. Like you can go with spotlight, okay, or you can go with different shades that are available over here. Tan, green, blue, yellow, light, anything that you like, you can use. I will go with spotlight. Okay, so what are we trying to tell? This mark, a kind of red, is your 60% of the goal. This yellow mark is 80% of your goal, and then we have everything above it filled with green. Okay, if you think everything above filled with green is also confusing you, don't use fill above. It's your choice how you design it. Don't use fill above. Remove it. Then you will get only this much. You get the actual target here. 80% of it and 60% of it is showing up. So what does it mean? I know very clearly, I know Amaretto, this product missed the target given to it, that you all agree. But we can notice that it has gone beyond 60% of the expected value. Its performance is not extremely poor. It managed more than 60% of the expected value, above average, you can say, right? And then it could not reach 80% of the expected value. It could not reach 80% of the expected value. So it went beyond 60%, but it could not be even 80% of what was expected. If you look at Cafe Mocha, same thing. It definitely missed the target. It went beyond the 60% target, 60% of the target, it missed the 80% target. Okay, then anything that has gone beyond 80%, mint you take. It missed the target, however it managed to achieve 60% of the expected value. It also managed to achieve 80% of the expected value. It just missed the target by a small margin. Getting it? We are not just showing the performance, whether or not they met the goal. If they have met the goal, that is fine. If they have missed the goal, we are showing by what margin it has missed the goal. Colombian is another thing which has gone above the 60% mark, above the 80% mark, well beyond the 80% mark. Just when it was near the goal, it missed it. So by a small margin, it missed it. So we are conveying a lot of information here. This is a bullet chart. This is a bullet chart which you can again create directly from the Show Me panel also. But we have created using the concept of reference lines and reference distribution bullet chart. You can also do it directly from the Show Me panel. You don't have to use this workaround or a long method actually. Just select product, select budget profit, select profit. I used it, I created using that method, so I can explain the concept of reference line and reference distribution as well. But in general, if you have to create a bullet chart, you don't have to struggle so much. Just select the measures and select the dimension. Select the measure and select the dimension. Two measures you have to select. It's compulsory. It's compulsory to have two measures selected. It is compulsory to have two measures selected, because if you go to the Show Me panel and you check bullet chart, you see the requirement 0 or more dimensions, but two measures. Less than 2, you cannot create a bullet graph. More than 2, if you have, even then you cannot create a bullet graph. If you want to create a bullet graph, definitely two measures. Only two measures, not more, not less. So because I met the criteria, bullet graph is active. When I click on it, the chart is ready. Do you think this chart is fine, or should we make any changes here? Observe the graph which I created through the Show Me panel and tell me if this is fine or whether we need to make any modifications here. Come on, please, all of you try to read this chart. Try to read this, try to interpret it and tell me whether it is correct or not. Correct, correct. Look at the reference line. What is the blue colored bar and what is the black colored reference line representing? So the blue colored bar would represent what is on your columns shelf. What is on your columns shelf? Budget profit, that is coming as a blue colored line, and the blue colored bar, and the black colored reference line is actually the profit information, which is on the detail shelf. Getting it? Nice, yeah. Okay, I hope all of you are able to understand it, that what is happening here is Tableau is doing it the other way around. It has put budget profit on the columns shelf represented with the bar, and the actual profit is coming as a reference line. Would this be correct? To show the actual profit as a reference line and the budget profit as a bar? It would not be correct. We have to swap. We need to swap. So what do? Right click on the axis. Right click on the axis and select the option to swap reference line fields. When you do this, whatever is on the detail shelf, which is profit on this graph, will move to the columns shelf. And whatever is on the columns shelf, which is budget profit on this graph, will move to the detail shelf. So swap reference line fields. Done. Now profit is coming up as a blue colored bar and the reference line is your budget profit. Now you will have to edit it and give it a more meaningful tooltip and all, but we'll leave it there. Okay. So that brings us to the end of module 6. Now we can begin with module 7, which is about advanced analytics that we can perform in Tableau. And in this module, we will cover scatter plots, trend lines, forecasting, clustering, distribution analysis, where we will look at histogram and box plots under that category. Then we will look at parameters and parameter actions. Okay, so that is the agenda for module 7. To begin with, we will discuss about what are scatter plots and how we create them in Tableau. All right, we'll start in a moment. Meanwhile, all of No, I was just saying that I'll give you all a moment here. You finish the bullet graph, and if you have any questions on anything from the previous module which we have completed, let me know. Otherwise, we will proceed to this module and start discussing scatter plots. All right. So I don't see any questions. Let's begin our discussion with another concept called as how do we create scatter plots. Even before we discuss on how to create a scatter plot, we need to understand what is a scatter plot and when to create it. Okay, what is a scatter plot and when to create it? Now, those of you from data science background probably already discussed this in the class and you are aware of it. But we have some Tableau participants, so I'll take you through the concepts once again. Now, one more time, we will do a recap of what we discussed so far. Different charts that we have learned. We learned about text tables and highlight tables, which are used, which is something that we create when we have an eye for detail, right? Where you will find it very often, you will find it in financial reports, revenue reports, sales reports, statements, balance statements. All these things are nothing but text tables. Then we discussed about different charts that come under the umbrella of comparative analysis. And this is a requirement that you come across very often. Multiple requirements you will have in every project for comparative analysis. So we have learned a lot of charts here like bar charts, side by side bars, circle views, then what? Heat maps, bubble chart, right? And yeah, there we can leave it so far based on whatever we have learned so far. And then there is something called as composition analysis, under which we have looked at how to create, under which we get the charts like stacked bars, right? And then pie charts. There's something called as donut chart, which we will learn later. Also what we saw yesterday, tree map, right? Proportions, proportion to whole, and especially hierarchical data. Proportion, sorry, go there. Sorry, proportion to whole. Right? And especially with hierarchical data, it is amazing. This chart is amazing with hierarchical data. Okay, so under composition analysis, we can say these things will come. Then there is trend analysis, or overall, what is the direction that the business is taking? Is it a positive trend? Is it a negative trend? Is it a constant trend, right? So when it comes to trend analysis, what type of charts? Whenever we have time series data, and what do we create here? Line charts and area charts will help us, right? Then what else did we discuss? Just a moment. Sorry. So time series charts are what? When we have time series data and we have to create time series charts, line charts and area charts will come in very handy. Then we discussed, then two things that are left out for us are correlation analysis, under which we look at scatter plots, and there is distribution analysis, under which we will look at histograms and box plots. All right. Now here, some additional charts that come under a separate category of comparative analysis. So comparing measures, when you have to compare measures against each other. Okay. Then we can use what we saw now, bullet chart and dual lines or dual axis. Dual axis, dual combination, and what else? Combined axis, right? So these are all the different types of charts that we have learned so far. And for every chart, we were also discussing on when to create them, not just how to create them, but also when to create them. So this kind of summarizes when to create which chart. Depending on the requirement, if you can just put your requirement into one of these categories, then you can go ahead and decide which graphs should you use for that kind of requirement. When we have, of course, we have a lot of options. So any of them will suffice, anything you can create. So if you have, let's say 5 requirements on comparative analysis, rather than creating 5 bar charts for each and every requirement a bar chart, you can try different other options also which are available. Okay. And we also discussed about text clouds. That is a completely different thing. So this information I'm going to send to you on your chat window. If you want, you can take it and save it in that notepad, which you are probably maintaining for the notes. Okay. I have sent it on the chat window. So anybody who needs it, you can please take it from there. So today, now, rank we will discuss. That we will discuss when we get to, that is a quick table calculation. Rank is a quick table calculation. We will discuss when we get to quick table calculations. Okay. Now, we are going to discuss about scatter plots. Scatter plots are used to perform correlation analysis on the data. Now, what does correlation mean or relationship mean? Why do we need to know whether or not there is a relationship between the two measures? Whenever we have to answer questions in this form, what will be the output given the input, or predict the output value, sorry, given the input value? Anything like this. When you have questions that are framed in this format, which are given to you on prediction, predicting the output given the input, what will be the output given the input, then it will be possible to predict the output given the input if and only if there is a relationship between the input and the output. There has to be some relationship between them. Okay, only then it will be possible to perform prediction. Like, for example, what will be the profit given sales? What will be the weight gained by a person given the calories consumed? What will be the power output in a power station given the wind speed in that location? So I hope you're able to understand that there has to be some relationship in it. If we have to predict some output, which we are going to call as Y, typically output is represented as Y, given some input X. So what we are trying to do is we are going to express the output, which is usually designated with Y, by representing it as a function of the input. Input is always represented using X. That is the general notation that we follow. Okay. So we are trying to express our output as a function of the input. But when will it make sense and when should we go ahead and predict is when there is a relationship between the input and the output. If there is no relationship, then we cannot do any prediction on that data. Like if I ask you, what will be the weight gained by a person given the wind speed in that location? Is there any relationship between the weight a person would gain and the wind speed in the location where they stay? Hardly any relationship, right? So when there is no relationship, we will not do any prediction. Only when there is a relationship, we will do prediction. Now, who will tell us whether or not there is a relationship? So that chart, which will tell us about whether or not there is a relationship between the input and the output given to us, is a scatter plot. Okay. So what is a scatter plot? Why we require it, I hope is clear. Now, when you create a scatter plot, it will take some shape. The data will take some shape. So you have y-axis, what we are trying to predict y, and x-axis, okay, on the horizontal. The input on the horizontal axis, x-axis, output on the vertical axis, y-axis. Based on the data that we already have in our database, we are going to plot it. On the xy coordinate plane, we are plotting it. If the data points take a shape like this, where overall you can see, now all of you I'm sure will agree this is positive. Overall, the data is moving in the upward direction, so it is positive. Then we can say that there is a relationship and the relationship is positive. Relationship is positive. Here also overall the data points are moving upwards, so we can say that the direction of the relationship is positive. Here, difficult to tell whether it's going upwards or downwards. If you think of it like this, then it's downwards, otherwise it's upwards. We cannot comment. It's not necessary that every time there has to be a relationship between the two measures. If there is no relationship, then you will get this kind of a plot where we can visually, by looking at the plot itself, tell that there is no correlation. Here, overall, the data is going downwards. So we say there is a negative correlation. Here also it is going downwards. Again, we can say there is a negative correlation. Sometimes if you have seasonal data, it's also possible to get a curvy linear relationship. Okay, like sales of ice creams. It goes down in winter, increases in summer, then goes down in winter, then increases in summer, right? When you have that kind of a curvy linear relationship happening, seasonal data, okay, where it goes up and down at regular intervals of time, then you can say curvy linear relationship. So once we create a scatter plot, just by looking at the shape of the data on the scatter plot, we can comment about two things. We can comment about two things. We can comment about one, the direction of the relationship, which could be positive, kind of upward direction, negative, downward direction, or it could be curvy, linear, if it is seasonal data, or it's also possible that there will be no relation, no correlation. Anything is possible. Second thing that a scatter plot will be able to help you to comment about is about strength of the relationship. How strong is the relationship between the two variables? Okay, how strong or how well are they correlated? It could be strong, the strength could be strong, it could be moderate, or it could be weak. If it is a weak relationship, then we will not do prediction. If there is no correlation, we will not do prediction. We will not predict the output given the input if there is no correlation. If it is a weak model, then also we will not go ahead and do any prediction. Otherwise, we can go ahead and do it. So what is this strength? Direction we have understood just by looking at the shape that your data is taking. Just by looking at the direction that your data is taking, you can tell whether it is positive or negative or curvilinear or no relationship. But what about the strength? We are telling that it also comments about another point called as the strength of the correlation. Strong, moderate, weak. Now, how do I comment about the strength? About the strength, we can comment by looking at how close the data points are. Okay. So we put something called as a trend line, or even if without a trend line also, just by looking at the shape of the data. Suppose I put a trend line. Okay, a trend line is basically nothing but a best fit line. Best fit line, the line that tries to go through as many points as possible. Now I cannot have a perfect straight line going through all the points. It will become a zigzag line, right? So a line that will go through a straight line. Let's take a linear relationship, okay? A straight line that goes through as many points as possible. And when you put that trend line, if all the data points are very close to the trend line, some of them are on the trend line, that kind of a thing, then we can say that the strength of the relationship is strong. Here it is strong. Here, some data points are on the line, some of them are little scattered away. You can say moderate relationship. Here, no relation, will not even try to comment about the strength. This is again moderate. This is quite strong. Getting it? Strength, just by visually looking at the data points, all of them are very close to each other and moving in one direction. You can say it is strong. They are a little scattered away like that. You can say it is moderate. Further scattered away like this, then it is a weak relationship and a weak model. All right. Now, so we can comment about the direction and the strength. Now let us see how to create a scatter plot. Now this is something I will show you with an example of my own, which I request you all to practice later. All right. Don't practice it now along with me. Even if you may not have the data source, even if you have it, don't do it. So here I have data collected from a power station. Okay, data collected from a power station. We have the power output, which is recorded in megawatts. We have wind speed recorded in meters per second. And what is it that we are expected to do? We are supposed to come up with an equation which will help us predict the power output given the wind speed. So the question we are trying to answer is this. Come up with an equation, express the power output as a function of the wind speed in such a way that I should be able to predict the power output when some wind speed is given to me. All right. So first of all, I have to do what? I have to check whether or not there is a relationship between the power output and the wind speed. How do I know whether or not there is a relationship between the two of them? I will go ahead and create a scatter plot. How to create a scatter plot? You can select both the measures, directly go to the show me panel and click on the scatter plot icon. How to create a scatter plot? Again, select both the measures, go to the show me panel and click on the scatter plot icon. That is how we create it. We will be doing it together also using sample superstore. Okay, so here you'll just observe and try to get the concept. Practicals we will do after the break. We'll do it together. So what should be on the y-axis? This is not a generic chart which you can design based on your own choice. Most of the charts, all the charts basically that we created so far, except I think for bullet chart, everything else are generic charts. You decide, you get to decide what should be the structure of your chart, what should be the structure of your text table, what should be the orientation of the bars in your bar graph, how do you want to stack the bars in your stacked bars, right? Everything is your choice. You design it the way you like. But scatter plot is not like that. You should have the output that you're trying to ultimately determine on the y-axis, because that is what we are trying to express as a function of the input which you have to plot on the x-axis that will be given to you on the x-axis. So power output which I'm trying to determine should be on the y-axis. Therefore, it should go to the rows shelf. Wind speed which will be given to me as an input from the client, that should go on the x-axis. Therefore, it should be on the columns shelf. But why is Tableau not showing me a proper scatter plot and giving me only one single mark here? It's giving me only one single mark here because why is it giving us a why only one mark scatter plot? Because the data in Tableau is always aggregated, right? Measures are aggregated. It is giving us sum of wind speed versus sum of power output. So what is it doing? It is summing up everything in the power output column, summing up everything in the wind speed column. Summation of those values is coming up here as a single mark. So this is called as a one mark scatter plot. Okay, but we have to tell Tableau that we are not trying to create a one mark scatter plot. We want to see the entire data. So how shall we do that now? We have to disaggregate the data or granularize the data. We will not be granularizing in this example. We will disaggregate. How to disaggregate the data in Tableau? Very important point. How to disaggregate the data in Tableau? Just go to the analysis option on the menu bar and uncheck or deselect aggregate measures. Okay, when you do that, for each and every row, whatever information you have, power output and wind speed, okay, all these data points are plotted on the xy coordinate plane here. So just by looking at the scatter plot, can you all please try to respond and tell me what do you think is the direction and what do you think is the strength of the relationship between these two measures? What is the direction and what is the strength? All of you will agree that it is strong and positive. I don't have any second opinion coming here. That is nice. Because usually I get mixed opinion on the strength. Some people say moderate, some people say strong, but that is nice. So all of you will agree that it is positive and it is strong. By looking at the direction, the shape, we can understand it is strong and positive. Good. Now, if I ask you, determine the power output if the wind speed is going to be approximately 8 meters per second. Will you be able to answer looking at the graph? Visual analysis. Just by looking at the graph, performing visual analysis, can you tell me what is the approximate power output that I can expect if the wind speed is 8 meters per second? Right? Approximately 10 we can say. 8 mark is here. 8 is the wind speed, then approximately 10 you can expect to be the power output, somewhere in this range. Okay, but maybe somewhere around 10, 11 we can say. Approximately we are talking. If it is going to be, let's say 15 meters per second over here, then I will go along that mark and say somewhere you can expect in this range, 25, 26. If it is 18 meters per second, I can say somewhere around 29, 30. Till here, I'm fine. I'm happy. I can comment about it. Now the client comes up with something new. They say that, okay, the weather department has forecasted that the wind speed is going to be 30 meters per second tomorrow. Tomorrow, the wind speed is going to be 30 meters per second according to the weather forecast. Now, what is the power output that I can expect to generate in my power station? Can we answer that question? 30 meters per second? We cannot answer because we have never encountered that kind of a situation in the past. We don't have any sample data for 30 meters per second based on which we can do our prediction or guess. We cannot guess anything. So now what do? Is we will put a trend line. So basically you just have to extend the shape, and approximately somewhere over here you can say 30, but it goes beyond the screen space. So what I will do is I will put a trend line. How do you put a trend line on the graph? Is when you right click on the chart, you will see an option called as trend lines. When you go and select the option show trend lines, Tableau will automatically come up with the trend line, which by default is always a linear trend line. Okay, it's linear. Now, when I hover the mouse pointer towards the trend line, you can see three things that will show up on the tooltip. Three things will show up on the tooltip. First thing is the equation of the trend line. Second is something called as R squared value. Third is P value. Now, the first thing that you're seeing is the equation of the trend line. So we had to determine what will be the power output given wind speed. We created a scatter plot. What did we do? Put a trend line. So on this trend line, what we get? We get the equation. Ultimately, we are trying to represent our output y as a function of our input x. So we put a trend line where it is telling us that the power output, that is y in megawatts, is equal to what? 2.24418 multiplied by the wind speed in meters per second plus some value minus 6.45, let us say. Okay, so what is this? This is the equation of a straight line. What is the equation of a straight line from our school days? Y is equal to mx plus c. M is the slope of the line, the inclination of the line, and if m is positive, the direction is positive. If m is negative, the direction of the relationship is negative. And c is the y-intercept. Y-intercept means if I extend this line to touch the y-axis, the point where this line will go and touch or intercept with the y-axis is called the y-intercept. Okay, so let's take data points like this. Let me take a data point like this. You see, what is this line? It is going downwards. What is the inclination of this line? Slope negative. Negative. Okay, and if I extend this line to touch the y-axis, somewhere around 50 it is going to touch, it seems. All right. Here, what is the inclination of this line? Positive. Slope is positive. And where will it touch the y-axis? At 5.8. That is the slope of the line. All right. So we are getting the equation of a straight line. Y is equal to mx plus c, where m is the slope of the line, inclination of the line, and c is the y-intercept. This is nothing but regression line. Correct. This concept is nothing but regression, but in Tableau will not be using the term regression as such. Trend line. Okay. What you learn as regression in your data science is the same thing. It's the same. Okay. So now, given the this is the equation. So I hope equation is clear to all of you. Next, what are we seeing on the trend line? We have seen something called as R squared value. This is the coefficient of determination. If this R squared value is greater than 0.8, then the strength of the relationship is strong. If it is anywhere between 0.65 to 0.8, then the relationship strength is moderate. Anywhere less than 0.65, then the strength is weak. If it is weak, we will not go and build any model on top of it. We'll not build a regression model on top of data that has a weak relationship. Okay, so we'll not do any trend analysis on that data, trend model. We will not build a trend model basically. All right. Next thing that you see there is something called as P value. This will determine the significance of the model. Okay, now any model that is built with a confidence interval of 95%. Any model that we build in the analytical world, not just in Tableau, generally anywhere across all the domains, 95% confidence interval is accepted, except for life critical domains like life sciences, nuclear sciences, where you cannot say that I'm only 95% confident that my model is accurate. There's a 5% chance that I would be wrong. When we say that, it would be quite a threat to the humankind, right? Nuclear science and life science. But most of the other domains, 95% is an accepted uh, criteria. Okay, so we are operating at a confidence interval of 95%, which means we are keeping 5% room for fluctuation. What does it mean? It means this. Now, the client said what? That the wind speed is going to be 30 meters per second, or let us say 100 meters per second for calculations. Okay, it will be easy for me to calculate. So I will use 100 meters per second. The client told me that the wind speed is going to be 100 meters per second. So predict what is going to be the power output. What did I do for that purpose? When I was asked to predict the power output, given the wind speed as 100 meters per second, first thing I did is I created a scatter plot. When I created a scatter plot through the visual analysis only, I was able to understand that it is a positive relationship and the model seems to be a strong model. But to corroborate my visual analysis, I did not just go with what I look at and determine. There's a lot of subjectivity. Different people might have different opinions when they look at this graph, right? So we'll not leave it to subjectivity. We are going to confirm our analysis. So what did we do? We put a trend line. When we put a trend line, what did we get? We got the equation of the line. And by observing the equation, when I observe the slope to be a positive number, I know that the direction of the relationship is positive. And then I observe the R squared value, which is 0.95, much greater than 0.8, which means I also can confirm that it is a strong model, strong relationship. Okay, direction is positive. I know because the slope is positive. It is a strong relationship, which I know because the R squared value is greater than 0.8. Then significance of the model. As long as the p value is less than 0.05, the model is considered to be a significant model. Means we can rely on that model. Okay, depending on the accuracy of your data, depending on how well the data that is collected is, you can get a p value which is way less than 0.5. Very significant model, but we operate at a confidence interval of 95%. So as long as p value is less than 0.05, we are good to go. All right, it could be way less than 0.05 depending on the data. If the data is good enough, you can get a much smaller p value and increase the significance of the model. Now how will I determine the power output given the wind speed? I will simply substitute here. I will give this equation to the client and tell, okay, this is your equation, go ahead. Whatever is your wind speed, substitute there and you can compute the power output. Okay, so they will go ahead, they will say, okay, I want my power output to be computed, which is equal to 2.2418 multiplied by the wind speed is going to be 100 meters per second plus the y-intercept is minus 6.45. And when we do the computation, what we get? Approximately 218 you will get megawatts of approximately 218 megawatts you can expect the power output to be. Till here, are you all with me? Any questions? Any questions or doubts so far? What we are doing, why we are doing, how we are doing? No, we'll not give the exact value to the end user. That is what we are going to discuss about next. This is what we got. But we'll not give exactly this value. What we will do is, we will compute 2.5% of that value. We will give this value plus or minus 2.5%. Getting it? So let us say that is what is confidence interval of 95%. We are saying we are operating at a confidence interval of 95%, which means we are in a way saying that we will put 5% fluctuation. How will you put that 5% fluctuation? Now, for my convenience, let us say we obtained the power output as 100 megawatts. Then what will we give to the client? We will tell that the power output will be anywhere between 97.5 megawatts to 102.5 megawatts. Why this much only? Why plus or minus 2.5? Why not 90 to 110? Why not 80 to 120? Why are we not using a very big interval range? Why are we using this small range? That is the default. Getting it? That is the default. Because we are going with the confidence interval of 95%. So we will put only 5% fluctuation, which is plus or minus 2.5 of whatever we have obtained. And we will say this much. Okay, so it will fall anywhere in that range is what we are going to tell to the client. All right. Now, trend line is basically to determine the equation for the data. Correct. Okay, now three more points we have to discuss here. Till here, I hope you're all okay. Now, yeah, but we will not just say it will be 100 to 105 again, Ganesh. If you have obtained the output as 100, you will not say it will be 100 to 105. You will not say it will be 95 to 100 also. Instead, you will put a plus or minus 2.5 on either side. Generally, we do a plus or minus 2.5 on either side. Yeah, 5% divided into plus or minus. Correct. Yeah, correct. Yeah. Now, here, this data that is inbuilt, Namita. How can we inform the model that we need 95% confidence interval? In Tableau, we cannot do that. In Tableau, the model is built with the confidence of 95%, which is inbuilt and cannot be edited. If let us say your client comes to you and says increase it to 98% accuracy, make it 98% confidence interval, 99% confidence interval, we cannot do that in Tableau. We cannot do that. You have in R and Python and all, you can change it, but in Tableau, we cannot do that. It is inbuilt. Is it mandatory to keep output value on y-axis and input on x? Yes, 100% mandatory. Because you're trying to express your output, which is designated as y, the power output, as a function of the input. Mandatory. Correct. Sabahat. Correct. So if your client is telling determine the power output, that should automatically go on the y-axis. Okay. If your client says determine the profit, that should be on the y-axis. If your client says determine the weight gained by a person, that should go on the y-axis. So whatever you're trying to determine will go on the y-axis. Okay. Now here in this example, we have data collected from three different locations actually. We have data collected from location A and location B and location C. Three different locations. Would it be right to use information coming from three different locations and create only one model for it? Right, funny. Dependent variable on the y-axis, independent variable on the x-axis. Correct. Would it be right to take data collected from three completely different locations, A, B, and C, and create one model for it? No, right? Okay, I hope all of you will agree. Even those of you are not responding, I hope you're following. Okay. It is not possible that I will take data from completely different locations and say that put them together, create one single model out of it. Wrong. So based on whatever we have learned so far, how do you think we will separate this now? How shall we separate this now? Separate. We have to separate it. So one thing is you can take location to the column shelf. You will get location A separately, location B separately, location C separately. You can take it to the row shelf. You will get location A separately, location B separately, location C separately. You can also take it to the filter shelf and one by one you can put, right? One by one you can put filter, like for example, I will show the filter. And so for location C, this is the data. Data looks good. R squared value is better than what it was earlier for the combination, and we can see the equation. Now let's see what will be the situation for location B. This is also good enough data. Then let us see what is it with location A. Location A, the data is not good enough. Looking at it only, we understand it's all scattered. It's quite widely spread out, right? So we can see the R squared value has become very less, means it is a weak model, weak relationship, right? So what are we doing? We are looking at the data per location now. Another way of doing it in a very efficient way, what we can do is we can take that location to the color shelf. When you take a dimension to the color shelf, Tableau will compute the trend per color automatically. So location A trend separately computed with a separate trend line shown there. Location B trend computed and the line shown there in orange. Location C data in red and the color of the line in red. So this we can do in Tableau. Okay, you can automatically very easily break down your analysis and you can separate your analysis by using it on the color shelf. Okay, so take a quick break of 5 minutes here. We'll come back and continue our discussion on the same concept. I'll see you all in 5 minutes time. Shape, if you use, you will not get different trend lines. Only for color, we have this option. Suppose I use location on shape. Each member may come up in a different shape, but the trend line will be a single trend line. So color has this feature, not shape or size. Okay. Color compulsory. Then you want to show them with a different shape, you can do that. You can do that. All right. Okay, I'll see you in 5 minutes time. Please take a quick break of 5 minutes and come back. Thank you. Hello everyone, hope you're all here. So we'll continue our discussion. So we are discussing about what is a scatter plot, when to create it. Now we're looking at how to create it and what is it that we get or gain by creating a scatter plot, the information. Like we get the equation of the trend line, which will also, we also get to know about the strength of the relationship and the significance of the model, which in Tableau is predetermined or fixed at 95%. Okay, it cannot be modified to anything else. That is how Tableau works. So what do we do when we get the equation? We will substitute whatever input is given to us in that equation, and we will be able to determine the output. However, because we are going with a confidence of 95%, the model itself is built at a confidence of 95%, we will always put a plus or minus 2.5, which is 5% fluctuation there. Okay, now in this particular scenario where we created a scatter plot, we have collected data from 3 different locations, and using a single trend for the entire data may not be correct. Therefore, we have decided to take the dimension to the color shelf, and Tableau will automatically compute trend per color. Okay, now let me right click on the chart again. When we go to trend lines, there is an option to edit the trend lines. After you have shown the trend line, you will see that there is an option to edit the trend line. Now, when I select the option to edit the trend line, the dialog box which will help me to edit it will come. And you can see this section here, the lower section. Build separate trend lines based on the following dimensions, location, which is on the color shelf, because it will allow a trend line per color only, not for any other shelf there, only per color. Suppose I uncheck show a trend line per color, then even though we have color coded the chart, trend will be computed taking the entire data into account. So if your intention is simply to beautify the chart, make it look visually appealing by putting different colors, however, trend should be computed for the entire data, then you can always say that you do not want to allow a trend line per color by deselecting that option. Okay, now show recalculated line for selected or highlighted data points. As you might have noticed already, when I select certain data points, Tableau is showing me the trend for those data points which are selected. Okay, or for highlighted data points, if I use the highlighting feature of Tableau, only for the highlighted data points, it's going to show me the trend line. The underlying trend line is always there, but for highlighted data points, it will show you again. And all the information comes up on the tooltip. So that is why the other option, which is called as show tooltips, is always active. Show tooltips, allow trend line per color, show recalculated line for selected data points or highlighted data points. Then the other option is force y-intercept to 0. If you think y-intercept value is not very significant, if it is a very small number and it's not so significant in your analysis, you can always force the y-intercept to 0. When you do that, the trend line will be forced to pass through 0. Okay, then we have show confidence bands. As I told you, we are not going to give the exact value to the client. Instead, we put a fluctuation of, depending on whatever your model has calculated, it'll give you the fluctuation. So that is what we are seeing here in the form of reference bands, that fluctuation. Okay, then this section is quite simple. Actually, what becomes significant is to understand which model to use. Now, Tableau supports 5 different trend models. You cannot create anything beyond this. Okay, especially the data science participants, you might have learned a lot of trend models under your regression lesson, but Tableau will support only 5. Okay, so when do we go for which trend model? When should I select which trend model for my analysis? This is the next point we'll discuss. Okay, usually I will tell you at a very high, in a normal way, in a simple way. Usually, depending on the shape that your data takes when you plot the data on the scatter plot, you decide which model to use. If your data is taking a shape like this, overall the data points are kind of in a linear fashion moving upwards. Or if your data is taking a shape like this, overall in a linear fashion, your data is moving downwards. Then you go with a linear trend model. Depending on the shape that your data takes, you choose the model. If your data is kind of linear in shape, then you go with a linear trend model. Then logarithmic. When you create the chart, if your data is taking a shape like this, where initially the rate of increase is high, after a certain point it kind of flattens, or initially the rate of decrease is high, after a certain point it flattens, then we go with a logarithmic trend model. Okay, then we go with a logarithmic trend model. Then exponential. So when you create a chart, if your data is such that initially the rate of increase is low, after a certain point it shoots up, or initially the rate of decrease is kind of low or linear, after a certain point it shoots down, it increases exponentially, or it decreases exponentially after a certain point, then we go with an exponential trend model. Next, polynomial we'll see. Okay, if your data takes a shape like this, where it is fluctuating, okay, then you go with the polynomial trend model. Now when you go with the polynomial trend model, you also have to mention something called as the degree of polynomial. If you go, how do you determine what should be the degree of polynomial? Depending on either the number of peaks in the data or the number of troughs in the data. So if I call the number of peaks to be n, then the degree of polynomial will be n plus 1. If the number of troughs, if I count, that is n, degree of polynomial will be n plus 1. Number of peaks in your data plus 1, or number of troughs in your data plus 1. Number of hills plus 1, number of valleys plus 1. Number of highs plus 1, number of lows plus 1. Anything. N is basically either the highs or the lows. Okay. Then all of these graphs, if you observe, they will have data starting at very close to 0. All of them are starting at very close to 0 on the axis. Okay. If your data is starting at a very high value, not 0, but at a very high value, the initial observations only are at a very high range. They're starting at a very high value. And if your data has at least one bend, then you go with power. Your data could be like this, it could be like this, it could be like this. Okay, it could be like this, anything. If your data has at least one bend, one curve, and it is starting at a value very high, not close to 0. In the range of values that you have, you don't have anything close to 0. Observations close to 0 you don't have. At a very high value it is starting with a bend, at least one bend. So all these data, they have a bend here, they have a bend here, this has 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 a bend here, like a curve. But it is starting close to 0, so I'm going with a more relevant model. Here it is having a curve, but it's starting at a value much higher than 0. Then we go with power. You can go with power in that case. So basically, looking at the shape of your data, you can determine which model to use when. Okay, depending on the shape of your data. Another way in which you can decide which model to use when, to be even more precise. Okay, looking at the shape of the data, I take some decision, but can I be 100% sure that I made a good choice of the trend model that I have selected for this data? How do I know that? You can check the R squared and the P value for different models. That is another way of doing it. Okay, now when I go with a linear trend model where the equation is y equal to mx plus c, I observe the R squared value is 0.95, P value is way less than 0.05. I am happy with this model. But let us experiment. Let us experiment with other models. On this data, which is more or less like linear, let us use a logarithmic model and see what happens. Logarithmic model, if I use, what will happen? You obviously, the equation will change. It is not the equation of a straight line, it is the natural log. Okay, it's the log equation. So 12.4786 multiplied by natural log of the wind speed plus the y-intercept. R squared value went down. From 0.95, it has reduced to 0.8. Okay, so we will say this is definitely not an improvement over linear trend model. Using this data, using logarithmic model on this data is not correct. Accuracy, as I told you, we just go with the confidence interval of 95%. Okay. Now let us use exponential. No, Tableau will not automatically select an appropriate model depending on the shape of the data. It will always give you linear model no matter what your data is. That is the problem with Tableau. It will give you linear model no matter what your data is like. You have to go and you have to change the model if you think it is not appropriate. Default is linear, and that is what Tableau will give you always. So on this data, if I use an exponential model, look at the R squared value. Equation is that of the exponential line, and the R squared value is much worse. From 0.95 for linear, it went down to 0.8 when we use logarithmic. It came down to 0.7 when we use exponential. So these are not the right models to use on that data. Definitely not better than linear. Let us try polynomial. Power I will not do here. I will do with polynomial. So polynomial, when I use, I'm getting 0.96 with a degree of 2. With a degree of 2, you will get a quadratic expression equation. Actually, it's a polynomial model, right? What you get is a quadratic expression. Ax square plus bx plus c. Again, depends on the degree of polynomial. Suppose you change the degree of polynomial and make it 3. So you see, you have this part, this bend taken care of. You have this bend also taken care of. Everything, all the data is, I think this is definitely an improvement. You will get what? You will get the expression, quadratic expression anyway. So you can see this, but don't overfit. Sometimes this may also result to something called as overfitting. Okay, we should not do that. You can leave it. R squared value of a perfect one is not acceptable again. Perfect one, if you're getting, either you have done overfitting or your data is not good enough, is corrupted. Okay, so don't do overfitting. Don't try to fit the line in such a way that it will go and exactly match the data in the pattern in your data. Don't overfit, but don't underfit also. Just use whatever you think is kind of giving you a relevant or appropriate information that you can work with. Okay, so that is about trend lines and scatter plots and trend lines actually. All right, here I will stop the discussion. If you have any questions, let me know. Otherwise, we'll do this using sample superstore data. Usually Tableau is an intelligent tool. Okay, Ganesh, and we can rely on it significantly. However, with trend models, what is happening is it is designed in such a way that it will give you linear all the time. So sometimes it may not be correct to use a linear trend model. This is one place where you have to experiment a little to choose the best model. All transformations are applied on the X variable. Yeah. Input variable. Yeah. Yes, Ibrahim. Okay. Even in Excel, what? Linear is the default. Oh, okay. Even in Excel, linear is the default. Okay, now let us use sample superstore. Let us say we are trying to determine the profit given sales. So how do we create a scatter plot, all of you? Try to create a scatter plot, profit versus sales. You will select profit, you will select sales, go to the show me panel, click on the scatter plot icon, your scatter plot is ready. But the scatter plot that we get is a 1 mark scatter plot. Okay, can we apply different model on different locations? No, Namita. If you have to do that, Namita, on a single worksheet, not possible. So for location A, you can create one worksheet, use some model there. Location B, you create another worksheet, use another model there. Location C, you create another worksheet with a different model. But on a single worksheet, you cannot get 3 different models for 3 different locations. Okay. If you're forced to do something like that, then you create a separate worksheet per location. So when we do profit versus sales, profit is what we are trying to determine, therefore that should go on the y-axis. Sales is what we have as the input, so we will put that on the x-axis. Profit versus sales, we get a 1 mark scatter plot because we know that measures in Tableau are aggregated. So what do? We can either go ahead and disaggregate the data. Sometimes you may have to disaggregate, but sometimes the client may ask you to granularize the data based on some dimensions. Granularize means what? We are looking at the overall profit and sales. Now I will break it down by region, for example, on the color shelf. So I'm looking at a data point per region. I have granularized the data. Tableau is now computing sum of sales and sum of profit per region. Okay, further I want to granularize. State I will take to the detail shelf. Okay, so I can see some states are actually giving me a loss. Some states are giving me a profit. So we have both profit and loss kind of a trend going on here, right? What you can do when you have data like this is you can break your analysis. You can segregate the data. By default, when you select two measures, Tableau's recommendation will be scatter plot. But you will also see some other charts are active, right? Not just scatter plot. You can create a text table, you can create a bar chart, you can create a scatter plot or a bullet graph. 4 options are given to us. When we select profit and sales, 4 charts are active. We have chosen to create a scatter plot because we are trying to do trend analysis here. If it is just that you are trying to compare profit against sales, you can create a bullet graph like that. So this is blue bar is representing profit and the gray shades and the reference line is representing sales. Or you can have a bar graph. You can have anything you can have, right? You can have anything, but here we are trying to create a scatter plot. Therefore, we have chosen scatter plot. Okay. Scatter plot is Tableau's recommendation. That's all. All right, coming back here. So when you have data like this, positive, negative, both, and you're not able to determine what to do here, okay, if you want, you can also break this. So you right click on the axis and choose edit axis. Force the axis to start at 0. So by default, Tableau will choose automatically whatever is the best range of values that it is supposed to put on the axis. When you go with fixed, you can change the start and the end. So I'm going to force the axis to start at 0. Means what? I'm ignoring all the loss transactions. I have ignored. 0 and above I'm taking. Now what happens? I have only positive countries which are contributing positively. And now if I put a trend line, I can see what is the trend of this data. Now per color, it is giving you a trend. Let us remove that. Let us say we don't want a color per trend. We just want one trend line. We are color coding to make the chart look beautiful. All right. So you can do this. Even then the data is not good enough. We are getting 0.48 as the R squared value. Maybe we can use a more like, this is more like exponential kind of, no? So maybe we should go with the exponential model here. That may power is looking better. Whichever line you think is fitting the best, you can go with it. Okay. So that's about trend lines. This is definitely not correct. Yep. All right. So that is about scatter plots and trend lines and how you put them, how you determine what is the best, and decide which model to use. Okay. Now you can further granularize this data. Let us say you have to look at this information for different order IDs. Bring that to the detail shelf. Now we are getting information for different order IDs, for all the different order IDs that are available over there. Okay. How to go to trend lines option is you right click on the chart, go to trend lines and select the option edit trend lines. Okay. And then you choose from the options that are available. Now, after you have done everything, you can also right click again on the axis, go to trend lines. There's an option called as describe trend model. When you select describe trend model, you get all the statistical information pertaining to the model that you have built. Okay, so it's a linear trend model which is computed for sum of profit given sum of sales. Model may be significant at p less than or equal to 0.05, which means confidence interval is greater than or equal to 95%. Then model formula, modeled observations. These are all statistical concepts. If you want, you can take them, copy them, and send it to your data science team for further analysis on the data. But from Tableau's perspective, this is as much as we do. Okay, as a Tableau developer, this is as much as we do. All right, so that brings us to the end of our discussion on scatter plots. I will send this text also on the chat, especially for the Tableau participants. If you think it will help you, you can copy this and use it for your reference. Okay, whatever discussion we had about scatter plots. Just go through the recording again if you want to, or practice the concept with windmill data that is given to you in your data sources folder. It should be there because you have an assignment on this. Okay, you have an assignment that you have to solve using the windmill data for scatter plots. So try it out, and if you have any questions, let me know tomorrow. Today you all practice, today and tomorrow you practice, and tomorrow or day after, whenever you want, you can ask me questions if you have any. Okay, so we can say we have completed trend lines and we have completed scatter plot. Next is forecasting, which is a very big concept again. So I will not start forecasting now. We will do that tomorrow. It will be fresh in our mind. We can do that tomorrow. Clustering we'll do. It's a simple concept. Okay. Next concept we will do is clustering, which is a very simple concept. Cluster is a collection of data points. Cluster is nothing but a collection of data points. How do we bring the data points together? How, or which all data points would we want to cluster together or combine together and create a cluster is data points which are very close to each other will form a cluster, which are similar, which have a similar feature or a similar attribute, you can say. So we have discussed the concept of groups in Tableau. We have discussed the concept of creating a visual group after creating the graph, right? We had discussed that. On similar lines, cluster is also nothing but creating a group or a collection. Only thing is we will not go and manually select the data points on the graph and create a cluster. We will leave it to a technique called as k-means clustering method. Tableau has an inbuilt feature for clustering, which is called as k-means clustering method. So visual cluster, the visual group that we created, what did we do there? We manually clicked on the marks on the data points and then chose the paperclip icon to create a cluster, to create a group indicated with the paperclip icon. You all need to recollect that concept now. Now I'm telling that there is one more method of creating a cluster by using a statistical concept called as k-means clustering method. This falls under the category of data mining unsupervised techniques. Okay, now how will k-means clustering segregate the data points into different clusters? It will check the distances between the data points. It will check the distances between the data points, and the data points which are very close to each other, they will form a cluster, and they should be similar also. Okay. So how do we do this is, let's do with an example. Let's say profit versus sales only we will take, and we will take our scatter plot itself. And let me look at this data for different subcategories. It is too wide. Different states will do. Okay, we'll do different states only. All right, and let me swap this. Okay, I want something like this. Doesn't look so good. All right, so let us use this chart. We want to segregate these data points into different clusters. You can keep it like this also, it doesn't matter. So we want to segregate this data into different clusters, different groups: high profit, medium profit, low profit. Let us say I want to segregate it into different clusters, different groups. So I can see there are these data points with very high profits. This is my profit axis. I can see some medium profit here, and I see that there are also subcategory states which are giving me negative profits. So instead of manually selecting the data points like this and then clicking on the paperclip icon to create a group out of it, I will take Tableau's help and ask Tableau to use the k-means technique to segregate this data into different clusters. Now, how do I tell Tableau to do it? How do I tell Tableau to perform cluster analysis on this data? Is you have to go to the analytics pane. Now, so far we have discussed how to put reference lines. So you can see reference line, band, distribution, box plot, all are here. Constant line, average line. Also you can put median with quartiles, you can put box plot, you can put. So average line with some confidence interval of 95%, median line you can put, trend line you can put, cluster analysis, forecasting. All the features that are available here are available on different menus and from the analysis option on the menu bar also. Okay, so these features that you see here are referred to as instant analytics. All the options that you see on the analytics pane, they are available even from other places, from the context menus, drop down menus, analysis menu on the menu bar, etc. They are referred to as instant analytics. And cluster is the only feature that is not available anywhere else. It is available only on the instant analytics pane. Okay, so when you drag cluster, when you start dragging it towards your graph, you will get a pop-up to create clusters. And when you take the mouse pointer on the graph there, the graph turns pink. Okay, when you leave it there, cluster will get formed. Tableau will automatically segregate your data into different clusters. So what did it do? These two data points, it has put it in one cluster, cluster 2, and all these data points which are very close to each other, they have gone into another cluster, cluster 1. Tableau did this. We didn't interfere. We just dragged cluster and dropped it there. Tableau decided to create the clusters like this. Only 2 clusters it's creating. Why only 2? It is Tableau's decision again. It is k-means logic. It has decided to create 2 clusters. If you want to change the number of clusters created, you can always do that. Let's say I want 5 clusters on this data. I will tell give me 5 clusters. So you see, this is one data point in one cluster. Here is one cluster. This is one cluster. This is one cluster. This is one cluster. I want 10 clusters. It will segregate depending on the number of clusters that you request for. By entering the value here, accordingly the number of clusters will vary. Data points which are very close to each other will come together to form a cluster. You can see that happening also, right, visually. This one data point far apart is one cluster. This data point is one cluster. This data point is one cluster. These data points very close to each other have formed one cluster. These data points very close to each other have formed one cluster. This is another group. These two have come under one group. These two have come under one cluster. This is one single cluster. This is one single cluster. Automatically, Tableau will decide what is the optimum number of clusters to be created on that data, which you can change by giving a number here. Let's say 5. How will it help you with your analysis? Okay, we are segregating the data like this, but what is the use? How is it going to help me with my analysis? So when you create a cluster, what happens is you will see a cluster pill on your marks card. It is color coding the cluster, so it is on the color shelf. When you drag this and drop it in your data pane, when you drag and drop it in your data pane, Tableau will save it as a group field. You see paperclip icon with cluster icon on it, state clusters. Now, however you use your group, similarly, you can use this. You can actually create a chart with showing the members in the data points there. So 5 clusters, cluster 1, 2, 3, 4, 5. Now I want to see what is the total profit for each, for the data points in each group. So cluster 1 profit is so and so, cluster 2 profit is so and so. Getting it? Like that, you can create any report subsequently after you have created the clusters. Okay, that is about cluster analysis, or k-means cluster, which Tableau uses to create clusters in Tableau. Please replicate this and then we will proceed further. Or maybe today we discussed quite complex topics, so we will stop it here. Yeah, whatever we have done so far, all these things are available on Tableau Public. Okay, so here we will stop our discussion. Tomorrow we will do forecasting, and then we will proceed to another very important concept called as distribution analysis. Okay, if possible, just refer to I think it's okay. That's it. Okay, thank you all. I'm going to stop the recording. I'll be on mute. I'm available to take up your questions if any.